Hey guys, this video opens a new topic for you, lines, angles, and polygons, alright? So this new series, and I start doing angle properties. So I start considering angles. So angle properties, basically everyone knows from your early study, so that basically angle is one vertex, so two arms, and you can measure in degrees or in radians. So actually up to this stage you definitely need to be able to measure angle, but there are a few tasks about measurements. So basically if you want to measure, you can use protractor, means specific tools with a scale. Just go around and it's 180 to 0 and way back, so from 0 to 180. Okay, but as I said, there are a few tasks in GCSE about measurements, and so probably you need to be able to calculate. All right, so let's consider properties. So that's significant topic where you can apply to whole geometry and trigonometry and almost everywhere where you barely touch angles. All right. So first of all, let's try to classify angles and let's have a look at what type of angles might be. So let's say if you have right angle, that's 90 degrees. So there might be two angles within. So always, and this is the typical, that's typical approach. If you have like the whole part, it will be consisted of like smaller parts. So in this case, for example, you have right angle, and if you split with another line so that you have alpha and beta, so two angles, you definitely be able to complete the following equation, right? So if you add them up, you'll get 90 degrees. So basically, you understand that two parts within the greater part arrange this greater part. In this case, the greater part is 90 degrees, but it consists of alpha and beta. All right, so how do we call those angles? They call complementary, because if you add them up, they arrange 90 degrees. So complementary. So complementary angles. All right, what if you have open angle, 180 degrees, basically a straight line, and here is the vertex, so 180 degrees. Obviously you can also split into different parts. So this is alpha and the rest part is beta. So alpha and beta together will give you 180. In this case, they will be called supplementary. Supplementary angles, and this is an equation that characterizes specific types of the angle. So okay, probably heard about adjacent rooms. So what it means in terms of the angle. So if you have common vertex, let's say O, and it shares actually several angles, for example 2 of them, let's say alpha and beta, so that's common arm is called adjacent, and those angles called adjacent angles. All right, so next one, if you have two straight lines which intersect in a single point, so what can you say about those values? So you have alpha. What do you think about this angle? It should be the same. That's actually vertically opposite. So vertically opposite angles. In this case, it's always the case when two angles the same. And for example, here you can consider and apply previous rules about actually supplementary angles, because if you add alpha and beta, you'll get 180 degrees angle or open angle. So in this case, this angle is also going to be better due to vertically opposite angles. All right, so that's basically the minimum classification that you need to be able to recognize in different problems. So the main idea and the main focus of the problems is the ability to recognize specific types of angles. So trying to find, trying to complete an equation related to the whole thing that is completed of smaller parts, and that's the main idea. All right, so let's consider other classification. For example, you have a point and it's split it up into at least 3 angles. So let's say A, B, and C. Instead of like Greek letters, now I use just Latin letters or English letters. So this is angle which is centered at the point. So what do you think about if you add degree measures of each angle together? So A, B, and C, so they will arrange 360 degrees. Okay, that's always the case. Okay, so corresponding angles. Let's find out what corresponding angles. So you probably heard if you have 2 lines and they're parallel, so that's why those like arrows means. If you have arrows, it's not actually the vector. Yeah, so actually it is sort of vector, but vector should have a starting point. So here just about to denote that 2 lines are parallel, so parallel lines. Okay, parallel lines. Okay, and what if you have another line, let's say blue line? Here you go. So obviously, if you start considering, let's say this is their initial angle A, so you obviously know that this is going to be also A is vertically opposite. But what about like angle B? So it's going to be somewhere, I guess here. Okay, so that's also angle A due to the property of second line, that's blue one, and 2 parallel lines. So A and this angle also be A. So here is going to be also A as vertically opposite. And so what about B? Supplementary, right? So A plus B is always 180 degrees. Okay? So those angles which I highlighted with yellow, okay, here and here, they called alternate angles. And they're always the same. Okay, so what about so angle, let's say angle B and angle here. So what do you think? I mark them as blue. So here and here. So this angle B, what do you think about this angle? Obviously, because this is A also, and together they will give you 180, so that's also B. They called corresponding angles. Okay, so angle B, I say angle A, alternate angles, and angle B, corresponding angles. Okay, so we've got that. So what about angles? Let's say this one, which is A, and this one, what do you think about its value? Obviously it's going to be B, because you see 2 angles are vertically opposite, but for example B and A relating to each other, that's called co-interior. Why co-interior? Because they're laid on the same side from the second line, so they lay on the left side and within 2 parallel lines. That's why they called interior. So core interior angles. And this is the case, so A plus B is always 180. All right, so as you understand, you can use like multiple properties to figure out like one angle through another, okay? And this is the basics. So in most tasks, try to complete equations and they will definitely help you. Even if you don't know angles for a while, just mark them like A, B, C, or X, Y, and try to complete equations, maybe several equations. If you complete it, it will be seen and it will be apparent how to cope with that. Just don't give up and don't try to say, okay, I don't know the angles and there are a lot of unknowns. I'm not able to solve this task. That doesn't work. It will work only if you be able to complete equations. Okay. So next one, let's consider a triangle. Obviously, you know what's happening in any, let's say, scalene triangle, in absolute any triangle, not only scalene. So for example, if we marked A, B, and C as angles, so you know that the main property for those angles is if you add them up, you'll get 180 degrees, okay? So what about exterior angle of, let's say, any shape? If you prolong, for example, this side, you'll have an exterior angle. I mark it as E, so that stays for exterior. And for example, how to find it? Okay, so use them as supplementary, and you know that B and E should give you 180. So in order to find exterior, you just simply express E or make it as the subject, okay? So in order to find E, you just simply need to express as 180 minus B, all right? That's how it works. So if you have, let's say, quadrilateral, just any, not necessarily parallelograms, it might be like arbitrary sides with different, you know, angles inside, let's say A, B, C, and D. So what if you add them up? In any quadrilaterals, there is the rule that will give you 360 degrees, okay? However, if you'll be able, only in the case, if you'll be able to inscribe this quadrilateral in a circle, I'll give you this rule a bit later, I mean when we consider circles, but just right now, for those who probably know that and curious about what if it's cyclical quadrilateral, so it means inscribed in the circle, so this is inscribed, okay, in the circle. So what about their angles? If I marked A, let's say B, and C and D. So here is the rule that for A and B together, they will arrange 180 degrees. It's always only for cyclical quadrilaterals that are inside the circle. So the same we can say about C and D. It's basically the idea of, you know, central angles and inscribe, and also an idea about, for example, let's say angles A and B covers the whole circumference. So that's why, you know, if you consider central angles, if it covers the whole circumference, the degree measure will be 360. However, inscribed angle is always half of the central, so it looks like they will cover only 180 degrees. Okay, so I'll prove when we consider circles. Don't worry, or check it out, this topic. I think it will be a bit later from this video. Okay, so yeah, that was basically the main idea of classification and what the minimum knowledge you need to have in order to be able to solve any task and any problem relating to angles. Okay, so for now I would like to consider several GCSE problems. For example, let's take the first one. So we have 90 degrees angle, and let's say we have a line that's placed 90 degrees angle on two parts. So this angle is, let's say, so it's better to mark x degrees, and let's say this one is 60. All right, what stays for x? Obviously x and 60 will give you 90 degrees, right? So, okay, we were based on the properties of complementary angles. So x and 60 are complementary. All right, so from here, x is just simply 30 degrees. So let's move next. What if we have a line and there are two parallel lines? Okay, it's not actually obvious that's parallel. Yeah, okay. So let's mark them as parallel lines. So what can you say about x value if you know that, for example, this angle arranged as an expression like 3x minus, let's say, 100 degrees. Okay, so in this case you have an expression for x is just one variable. However, here you'll have the whole expression. So don't worry, what do you need to do? Actually, because those angles should be equal according to the properties, so we can write an equation. Okay, so sorry, not plus, an equation. So x actually in degrees equals to 3x minus 100 because they're equal, right? So we consider as equal corresponding angles, if you remember the property. Okay, so in order to find x, we just simply need to find x variable solved as linear equation. So this sort of linear equation, all right? So in order to find x, we just simply transfer x here, while negative 100 we transfer to the left side. So we'll get 100 equals 3x plus minus x, because we need to change the sign, right, when we transfer. Okay, so 2x equals 50. Sorry, actually x equals to 50, and that's the final result. Okay, so next one, let's consider probably a bit more complicated topic. Not topic, but a bit more complicated problems. All right, for example, let's take this one. Say we have angle that is here. So we have 315 and we have a bisector of this angle, for example, like this. So this is the bisector. What does mean bisector? It means it splits angle on two equal halves, right? So figure out this one, okay? So x. So basically, because we know it's bisector, we know that this angle is also x. So 2x actually 360 minus 315. You know why? Because the total amount around is 360. Or you can start from just adding parts, like x plus 315 equals to 360. Okay, so if you simplify, you'll get 2x, and then you'll get 360 minus 315. Okay, so from here you know that if you subtract and divide by 2, you'll get the following. So 360 minus 315 is just 45, and 45 over 2 is so 22.5 degrees. Okay, that's the final value. All right, as you can see, it's not so hard. Okay, so what's next? So probably let's consider about parallel lines and second line. So you have like vertical line and two, say, parallel lines. Okay, so those lines are parallel, so you'll get x value, you'll get, let's say, y value, and you'll get this angle to be, let's say, 60 degrees. Okay, so find x and y. So what can you say about yellow angles? Y and 60, they're equal, right? Because vertically opposite. So because there are two parallel lines, angle x should be equal to y. So x equals to y, so that's why it's also 60. All right, what to figure out also? Maybe just a bit more complicated stuff. Okay, so let's take one 180 degrees angle, and split up on two like parts. Let's say this is x plus 30 degrees, and this, let's say, 2x minus 5. Okay, so how to figure out x from here? You know that in order to arrange 180 degrees, you just need simply to add those two angles, right? So that's why you just add those two angles, okay, and just simplify. All right, 3x here, 30 and negative 5, 25, and transfer here, you'll get 180 minus 25. Okay, you're just playing, you know, you're just playing with every single term as just blocks, like Lego blocks. Okay, you're just trying to transfer one side, changing the sign, and doing some operation. Okay, so 180 minus 25, you'll get 155 degrees equals 3x, and from here x is 155 over 3. Okay, that's an idea how it works, so you can figure out by calculating. Okay, what's next? For example, what if you have like more complicated like problem about really a lot of angles there? For example, here, and say there also. Say this is 30 degrees, and you know that other measures like 3x, maybe 2x minus 30 degrees, and here let's say x plus 50 degrees. Okay, so you have different angles. So what to do? All right, you know, arrange just 360 degrees from here, and you'll find the value. So I start counting from this one, let's say clockwise. Okay, this is the starting point. So 3x plus 2x minus 30, then plus x plus 50, and then plus finally 30. Okay, then I just simplify and try to find the value. So 360. So similar terms here, 3x, 2x, and x. All right, so we'll get 6x here, and then negative 30 and 30 is cancelled, so plus 50 only. Okay, so 6x is just 310, and then x is 310 over 6. Okay, that's an idea. Okay, so probably let's work out with shapes. Let's do it quick. All right, so for example, you are given the following shape, let's say parallelogram. So you know that the shape parallelogram is basically shape arranged. So this is quadrilateral, arranged by two equal opposite sides that which are parallel. And let's say here, opposite sides are also equal and parallel. So because it's parallelogram, okay, gram. So let's say you're given the value for, let's say 120, for example, and you want to find A and B. Okay, so in this case, what you can do, just you can remember properties, because if you prolong the side, it's also going to be A, right? So A is just simply 180 minus 120, right? Okay, because they're complementary, supplementary angles. Yeah, they're supplementary because 180 degrees in total. If you subtract, you'll find a value for A immediately. And what about B? So B is actually, because two lines the same, so B is going to be the same as A. So B value is also, oh wait, it's also 60. Yeah, it's also 60, right? Okay, let's figure out. Yeah, definitely the case. Yeah. All right, so that's how we can figure out the values. So maybe a more complicated problem. Let's try to see. Okay. For example, we might be given a trapezium. Say one angle is 90 degrees. However, here is not. So we have this. And let's say we have a diagonal. So blue is a diagonal. Okay, it connects to opposite vertices. So for example, you know, because you're given that it's 90 degrees angle, it will help you somehow. So in trapezium, you know that two bases are as parallel lines. Let's say you don't know this angle, and maybe you don't know this angle, and probably you don't know, let's say, this angle C. Okay, so try to find all of them. So try to find A, B, and C. Okay, so what to do? You know that because two parallel lines and the second line, so you consider A to be 90 degrees. Okay, so what about B? So how to find B? So it's 90. Yeah, I think you need to know some of the angle. Let's say this is 30 degrees, for example. Yeah, without this, you're not able to solve because incomplete data set. Okay, if it's 30 degrees angle, how to figure out B values? So, because two parallel lines, B is also 30, right? So B is also 30. Two parallel lines here in the second line. This is the second line basically. Okay, so what about C? You know, it's quadrilateral, and for every quadrilateral, if you add all those angles, you'll get 360 degrees. Okay, so let's add them up. This 90 degrees, this 90 degrees, this 30, and the last C. So you'll get 90 degrees plus 90 degrees, those two, then plus B, which is 30. Oh, okay, you don't know this. Okay, that's the problem. Okay, let's mark as new angle, say X. So plus 30 plus X and plus C should be equal to 360. Okay, and for the triangle, we can also figure out, yes, C plus X will be and plus 30. We add all those angles for triangle. In this case, we'll get 180, but I think it's again not enough data, so we should be given X, for example, in order to find C. Because you see what's happening. Let's take C and X. If we consider like two simultaneous equations, as the first one as the second, so C plus X should give you 150, right, from the second equation. But let's simplify the first also. 90, 90, 180, so if you transfer here, it will be 180 there, and if you transfer 30, you'll get the same, so X plus C is 150. So obviously, because there are two identical equations in the system, they actually repeat each other, right? And it's not enough, so you need to consider it as just only one equation, right? And for this reason, in order to find C, you need to know X. Let's say X is 50 degrees, okay? Now it's possible if X is 50 degrees, so C is 100 degrees then. All right, so we consider angle properties, we categorize them, we saw the application of angle properties in sort of GCSE problems and questions. So try to practicing, okay, and you'll get your maximum, the highest possible score on exams. And be with me, you'll find out really more useful stuff. Okay, thank you guys, and see you.